Greetings and welcome to the Plsql channel, a series of video trainings on the Oracle Plsql language. My name is Stephen Feuerstein, and I'm a Plsql developer just like you. This lesson is part of my series on bulk processing in Oracle Plsql, and in fact is the first lesson in the series, so we're going to be talking about introduction and overview. But first, to get the most out of this webinar, and in general all of my trainings, prerequisite is that you have a working knowledge of Plsql. I'm assuming you have already used the language to some extent. You just maybe haven't used the bulk processing features. And in particular, when it comes to working with the bulk processing features that I'm about to talk about, you will need some level of familiarity with collections. So if you haven't yet worked with those, do stop taking this lesson and go back and learn about collections. And in addition to watching videos on this lesson and others, you can also go to my toadworld.com/sf site, otherwise known as Plsql Obsession, and you'll find lots of trainings, PowerPoints, videos, resources, etc. that you can download and use to complement what you're learning in this lesson. In addition, you'll see references to files in my webinars, and those are all available in the demo zip file, which is also downloadable from the Plsql Obsession site. So take advantage of all these resources, and again, make sure that you have a comfort level of working with collections before proceeding with the series. So bulk processing in Plsql, the agenda, short and sweet. We'll talk about the problem with executing SQL in Plsql and why bulk processing was introduced. We'll take a look at the relationship between the Plsql and the SQL statement execution engines. And then I'll introduce at a high level the bulk collect and for all features of Plsql. And then future lessons will delve into detail in both of those. So what's the problem? Well, many of the Plsql blocks that we write execute the same SQL statement repeatedly. For example, we might be doing a loop through a cursor and retrieving the information row by row, or within that same loop or cursor for loop, we might be executing the same DML statement, update, insert, delete, over and over again. So what's the problem with that? Well, let's take a look at a piece of code. Here's a classic example of Plsql. We can take advantage of things like the %type anchoring so that we can tie the declarations of our variables straight back to the database column they're based on. I can declare cursors with native SQL, use the beautiful and elegant cursor for loop to iterate through all the rows in that cursor, run some complex adjustment formulas for my salaries, let's say, and then perform a DML statement. Now, this is classic Plsql and really demonstrates a lot of the beauty of the language, the simplicity of using Plsql with the SQL language. The problem is that while this is elegant and simple code, it could be quite inefficient. If I have many, many employees in a department, let's say thousands of employees in a department, I'll be fetching out the data row by row. I'll be updating or I'll be issuing an update statement for each one of those rows that are fetched. And this row by row processing can be quite inefficient. And I think this inefficiency is often a surprise to Plsql developers because we're taught that SQL and Plsql are so tightly integrated. Well, they are, but only to some extent. So let's explore this issue of how the SQL and Plsql engines communicate, and especially what that means for repetitive statement processing from Plsql. So there's the back end of Oracle, the Oracle server, but every element within the back end is not equal. There are layers of code even within that back end layer. And you have in particular the Plsql runtime engine, and that basically executes all your Plsql statements. And then there's the SQL engine, and that takes care of any SQL statements that need to be executed. When a piece of Plsql code is executed, the Plsql engine is executing each of the Plsql statements, but as soon as it hits a DML statement, an SQL statement, query or update, insert, delete, it stops and transfers control over to the SQL engine to basically ask it to do the execution of the SQL statement. And then the SQL engine passes the information back. So what you have is a constant process of switching back and forth. If I have a cursor for loop that retrieves 1,000 rows of data, and then I execute 1,000 different update statements, then we're going to see a switch back and forth 1,000 times between the Plsql and SQL engines. And these are, in fact, called context switches. And historically, context switches have been a major bottleneck in overall Oracle performance. And that's why if you went back to Oracle 7, Oracle 8 days, and you tried to execute your own function inside an SQL statement, for example, if I tried to execute something like this. Here's a call to my between string function, a simple string function like substring, and I'm calling it inside an SQL statement. And what you see here is actually the reverse kind of context switch. Every time the SQL engine needs to call the Plsql function, it stops executing, passes the request to the Plsql engine to run this function with the following parameter values, and then return the value back. So you can extend the SQL language by adding your own or calling your own functions inside SQL. But in the older versions of Oracle, the cost of a context switch was so high that very few people ever did this. With each version of Oracle, or the Oracle database, Oracle works on reducing the cost of a context switch. And that's why Oracle will often say to you, when your company complains about performance, they'll say, well, you should upgrade. You should stay current with the latest version, because simply by upgrading, you'll be able to take advantage of broad optimizations like a reduction in the cost of a context switch. But still, you might have a lot of context switches, and that can cause some significant overhead. So the core idea in the bulk processing features that we're going to explore in this series is quite straightforward. Reduce the number of context switches, and you improve the performance. So we'll reduce the cost of each switch, but even better is let's avoid doing a context switch altogether. And that's what you get with this new feature in Oracle. Essentially, Oracle bundles up the request for the data, in other words, querying data or even changing data, and then communicates that request to the SQL engine with a single context switch rather than multiple context switches. Now, there are two statements or parts of statements in Plsql that tie into the bulk processing feature. One is for all, the for all statement, and that's used to speed up DML. So you can basically use for all with inserts, updates, deletes, and merges. And what you're essentially doing is moving data from collections into tables. The other statement or extended statement is bulk collect, which we add to the into clause of a query. And that's for speeding up the retrieval of data. And you can use it with all kinds of queries, implicit, explicit cursors, static SQL, dynamic SQL. And the idea here is that it takes data from tables and moves them into collections in your Plsql program. So for all and bulk collect require the use of collections, which is why it was mentioned as a prerequisite for this series and this feature. And it allows you to communicate with the underlying database through the SQL layer using collections to manifest the bulk processing approach. Okay, so that's the general idea. Let's take a look at it in pictures. So back to the display of the Oracle server having two different engines, the runtime engine for Plsql and the runtime engine for SQL. And I showed you the for loop in which we went back and forth 1,000 times. Well, what I've done is now replace the for loop with a for all statement. Don't worry, in a next lesson you'll be able to see all the details of the for all syntax in lots of detail. But right now, just take my word for it, I've changed the for loop into a for all statement. And within the for all statement, I have the update SQL statement. So for all is Plsql, update is SQL. And now the performance profile, the way this works is quite different. So now as the Plsql statement executor is moving through the code, when it hits the for all statement, it stops. It looks at the DML statement inside of it. It checks the range of values in its header. And it says, oh, I'm going to be executing 1,000 update statements. Okay, so it generates all 1,000 update statements and passes it over to the SQL engine in a single context switch. And then in the SQL engine, all those different statements are executed, and then the information is passed back. The end result is that rather than having 1,000 context switches, I might have 1 or 2 or 3, whatever the actual number is, it's greatly reduced. So we get the same SQL behavior as we saw before, but at a much higher rate of performance because we're not paying the cost of switching back and forth and back and forth. So that's the core idea, the principle behind the bulk processing. And it's simply now a matter of learning how Oracle has provided the syntax for you in the Plsql language to make this possible. Now, in terms of the impact of bulk processing in the SQL layer, let's talk about that before we move on to the next lessons and explore each of these features from the Plsql side of things. Because the important thing to remember is that bulk processing, for all and bulk collect, are all about changing the way you write your Plsql code so that the Plsql engine communicates with the SQL layer in a different way, reducing the context switches. This is a Plsql feature. As a result, as you might expect, the processing in the SQL engine is almost completely unchanged. In other words, if you were having problems with rollback segments before, you will still have problems with rollback segments after you introduced for all. If you had a problem with snapshot to old with your cursors, quite likely you'll run into the same kind of problem as before. So the SQL behavior is the same as it was. And in fact, the same number of individual SQL statements will be executed. So the SQL engine behavior is largely the same. The only difference I'm aware of is that if you have a statement level trigger on a table in which you fire a for all DML operation, then the for all insert will cause the firing of the trigger only once per for all statement. So whereas if I had a loop with 10 inserts being executed, it would execute the statement level trigger 10 times. If you put that same insert statement inside of for all, the statement level trigger will execute just once. So as you decide to pursue and apply the for all statement into your environment, and you do it with insert statements, make sure you look at any statement level triggers and make sure that the logic in that will apply to the entire statement as a whole. If it's not, if you have to fire it for every single row or every single insert statement, then you might need to avoid the use of for all in this situation. Now you can take a look at the statement trigger and for all file, again available in my demo zip from the Plsql Obsession site. And what you'll find in this file is an example that simply walks you through the difference of impact of having a statement level trigger with and without for all. So I have a table with 3 rows in it. And I've put together a little package that will keep track of how many times my trigger is fired. We don't need to go through all the details right now. You can check this out on your own time. But basically, I've created a statement level trigger that says if I'm doing a certain kind of operation, then pass the name update, delete, or insert to my increment before and increment after procedures. And this basically writes some information to an array that keeps track of how many times I've run the trigger itself. And then in my code, for updates, inserts, and deletes, I execute an update on a row-by-row basis. So here's my cursor for loop, and I execute my update statement 3 times. And here's my for all statement with a single update. But I will actually generate 3 update statements. Now again, we'll come back and look in detail at the for all syntax, so don't worry about that right now. And I do the same thing for inserts and for deletes. Do row-by-row processing, and then for all based processing. Now, if my statement level trigger fires for every single statement, whether it's in the for all or not, then I should see a total of 6 when I run each of these blocks of code, because I'm doing the non-for all and the for all approach, 3 each time. If the statement fires just once in the for all, then I should see a total of 4 operations, or 4 firings of the trigger, 3 for the individual row operations and 1 for the for all. And in fact, let's try it out. When I run the script, I find the following. For deletes and updates, I get a total of 6 before statement and after statement executions. 3 for the row by row and 3 for the for all. But for the insert, the total is just 4. So I got 3 for the row by row, but only 1 for the entire for all statement. Again, this may not be something you run into very often. But as you move to for all, this is the only change that you should have to worry about in terms of the SQL engine side of things. There are lots of issues to look at on the Plsql side of things, and we have a whole lesson just on the for all statement and all the possible complications. But in the meantime, when you start to move to for all, do check out your statement level triggers. So to sum up, look for loops that contain DML statements. So in essence, when you're starting to look at applying the for all and bulk collect features, you're going to look for loops in your code, whether they're numeric loops, cursor for loops, etc., that contain DML operations inside them, inserts, updates, and deletes. And those will be prime candidates for conversion to bulk collect and for all. Look for row by row query logic. If I'm retrieving data from a table or set of tables in the back end, row by row by row, that can also be a great opportunity to apply bulk collect. And of course, you need to get into all the details for these features. I haven't really shown you very much yet at all. So the next step, make sure you download that demo zip file from the PLSQL Obsession site, try out that statement level trigger executor and make sure you understand what's going on there and reinforcing the point that I'm making that it fires just once for your for all insert. And then, well, get moving. Next lesson in this series is how to get data faster out of the database using the bulk collect syntax. I hope you enjoyed this lesson. Happy PLSQL coding, and I'll see you or talk to you in the next lesson.